Find each function value. We have a quadratic function, 5x squared minus 8x plus 6. First, we're going to substitute 2 into the function. Everywhere you see an x, replace that with a 2. Use your calculator or mental math, either one. That's 4, 20, minus 16 is 4, plus 6 is 10. So that's your function value when x equals 2. In the next example, substitute negative 1 in for x. 5 times negative 1 squared minus 8 times negative 1 plus 6 is 19. And then many times in calculus, you're going to see functions that get replaced by other algebraic terms. For example, you may be asked to substitute in a t plus 2. 5 times t plus 2 squared minus 8 times t plus 2 plus 6. Don't forget that t plus 2 quantity squared is 2 of them. Over here in the plum colored ink, t plus 2 squared is 2 of them multiplied out. So this is where I'm getting the t squared plus 4t plus 4. Distribute 5, distribute negative 8. We get 5t squared plus 20t plus 20 minus 8t minus 16 plus 6. Combining like terms, 5t squared plus 12t plus 10. In our second example, we have a piecewise function. The top piece is defined for any values of x less than negative 1. The bottom piece is defined for any values of x greater than or equal to negative 1. When using substitutions in a piecewise function, you take your number that's given, decide which condition is met, and then plug into that piece. Since negative 4 is less than negative 1, we substitute into the top piece. Negative 2 times negative 4 minus 2 is 6. F of negative 1, since negative 1 is equal to negative 1, we use the second or bottom piece. Replace your x's in the bottom piece with a negative 1. Simplify and you get negative 2 overall. Finally, we're asked to evaluate f of 1. 1 is greater than negative 1, so we're going to stick with the bottom piece. 1 squared plus 2 times 1 minus 1 is 2. Continuing with a piecewise function, we have a two-piece function defined as 9 minus x squared for x is less than 3, x minus 3 when x is greater than or equal to 3. We have a series of function values we're asked to evaluate, starting with f of 1, and we go all the way through f of 5. The top piece is used for any values of x less than 3, so these first two function values, we're going to use the top piece, and then once we get to 3 and any value of x larger, we switch over to the second piece. All right, so f of 1, 9 minus 1 squared, that's 8. 9 minus 2 squared, that's 5. Then we switch to the bottom piece. 3 minus 3 is 0. 4 minus 3 is 1. And 5 minus 3 is 2. Now, below we're going to go in here. We've got a grid, and we're going to graph both pieces, but only for the values of x for which they are defined. So if you want to pause and write these down, in order to keep it large on your screen, I'm going to pan up, and I don't want to go up and down a bunch to make you dizzy or to break concentration. So if you want to pause and write these down, go for it. These can also be found in your Google Drive folder. Okay, so here we go. We had the top piece of the function was defined as 9 minus x squared for values of x less than 3. So that's a parabola that opens downward and has a y-intercept at 9. We verbally plotted a few extra points. Back up at the top, we calculated f of 1, f of 2, F of 1 was 8, so we have the 0.18. We calculated f of 2 and got 5 as the answer, so 2, 5 is another point. We left an open circle here at 3 because if you were to plug 3 into the top piece, 9 minus 3 squared is 0. But because that piece isn't defined technically at 3, we leave an open circle. Once we go to the second or bottom piece, we had x minus 3. Well, that's a line with slope 1 and a y-intercept of negative 3. We don't draw the entire line because it's only defined for 3 or larger. 3 minus 3 was 0, so we put a filled-in circle at 3, 0. We calculated f of 4 to be 1, f of 5 to be 2, but since lines are very predictable, a slope of positive 1 is fairly easy to draw. Some math notation that coincides with x-intercepts. We have some problems in your homework where you're asked to find where f of x equals 0. As long as those are real numbers, those will be x-intercepts of your graphs. Our first function is linear because we have 2x to the first plus 8. If you were to draw this, you would put a dot on the y-axis at 8, and then your slope would be 2. If you were to trace that backwards, aka set your function value equal to 0, you get x equals negative 4. So the point negative 4, 0 would be the x-intercept of this function. The second function, we see an x squared, so that's a quadratic function. This one can be factored using x plus 3, x minus 6. You want to set your function equal to 0 so that you find the zeros of the function. X plus 3 equals 0 when x is negative 3. X minus 6, your other factor, is 0 when x equals 6. If you were to graph this parabola, it would be valley-shaped, and it would cross through the x-axis at negative 3, 0, and 6, 0. Find all real values of x, such that f of x equals g of x. These are actually the values of x at the intersections. Our function f is the quadratic function above, x squared minus 3x minus 18. If we're asked to set that equal to the line 3x plus 31, then we still have overall a quadratic term in the equation. So we'll bring all terms to one side, subtracting 3x's from both sides. That gives us x squared minus 6x minus 18 equals 31. And then to subtract 31 on both sides, you get x squared minus 6x minus 49 equals 0. Now, since this can't be factored using nice whole numbers, you can always fall back to the quadratic formula, and you can identify a as 1, b as negative 6, and c as negative 49. Put these numbers carefully into the quadratic formula, and you will get 6 for the upper left number. The discriminant is the value under your square root. Carefully calculate that. You should get 232. Your denominator, 2 times a, that's 2 times 1, or 2. Since 232 is not a perfect square, that's okay. You can approximate these values. In class, had you guys approximate these using your calculators. 6 plus square root of 232, all divided by 2 was 10.6. 6 minus square root of 232, all divided by 2, was negative 4.6. These are the two x values where these graphs intersect.